Okay, so complex numbers is the next thing we got to talk about. Remember, the gist of this chapter is solving quadratic equations, finding the x-intercepts. We did factoring earlier this week. We did square roots yesterday. If you didn't notice, this is a really long chapter, so I'm going to split it up into like 2 smaller chapters so you don't have to take a like Megatron-sized test at the end, okay? So we're going to take our first like half test on Friday. It's going to be factoring. It's going to be this. It's going to be this stuff, and then it's going to be one more thing that we do tomorrow, and then you'll take that test on Friday, okay? But complex numbers is going to play a part in that. So let's say you have this equation, and I ask you to solve it. What would you do? Subtract 24, you get 3x squared equals negative 24. Then what? Divide by 3, you get x squared equals negative 8. Then what? Okay, you take a square root. The square root of negative 8. What do you mean? Why wouldn't it work? Because I have a negative square root. And that does not make any sense. If you don't know what I'm saying, what if I asked you what the square root of negative 4 was? Do it. It doesn't work, right? Because 2 times 2 is 4, negative 2 times negative 2 is 4. You can't multiply something by itself and get a negative number. It doesn't work. What does it say? No way. That is so funny. What is that? Is that an app? Oh, that's so funny. I love that. Oh my gosh. That's really funny. I'm being serious. That's super funny. I think that's hilarious. All right, so here's the deal. Mathematicians back in the day came across this problem and they were like, what are we going to do about this? Can't have a square root of a negative number. So they came up with a solution. They said, well, let's just make up a number. And they called it I. The imaginary number I. It is defined as the square root of negative 1. That is what I is. It's a number that makes negative square roots possible. Okay, so if I is the square root of negative 1, then I squared is just negative 1. So you might be looking at that thinking, what the heck? Why is there a letter involved now? And it means a number, but it's a number that doesn't actually exist. Yeah, it's kind of weird. It's kind of wacky. It's kind of goofy. But I, being the square root of negative 1, makes these things possible. Makes it so that we can have square roots of negative numbers. And it's not a problem anymore. Okay? So you might think it's really weird. I'm going to make it seem less weird. So here's where it comes up. Let's say we were doing all these types of problems yesterday, right? Let's say I want to do it with a negative number now. Here's what I'm going to do. On this one, I'm going to show you the technical thing about what happens. And on this one, I'm going to show you the easy way. Okay? So here, technically, if I rewrite this as the square root of negative 1 times 2, well, that's negative 2, right? And then from the rule that we talked about yesterday, you can split this thing up. It turns into the square root of negative 1 and the square root of 2. Well, what did we just learn about the square root of negative 1? It's I. It's the imaginary number, I. So this turns into I. Square root of 2 is just square root of 2. And that's what we got. It's an I. I put a little tail on my eyes so that it doesn't just look like a 1. Yeah. It's not plus or minus right now because we're not solving anything. We're just simplifying. All right, so You don't have to write the -1 every time you do this. If it's helpful for you, go for it. But you don't have to do it. Here's kind of the trick that I use. If you have a square root and you have a negative sign underneath that square root, just know that it turns into an I, okay? So if there's a negative underneath the square root, it pops out and becomes an I. Now it's not negative anymore, and I can just deal with the square root of 8 like I did before. The I stays in front. Okay, so what are perfect squares that go into 8? 4 and 2. So it's 4 times 2. What's the square root of 4? 2. So here's what you might see. I, 2, root 2. But this looks kind of weird. Pretend that I is a variable. Write it as if it's a variable. You wouldn't write x2, right? You would say 2x. So we're going to do that here. We want to write it as 2I root 2. Let's make a little bit of sense. Pretty radical. All right. Let's talk about D. Square root of -36. What is true about 36? It's a perfect square number. What is the square root of 36? 6. But what does the negative under the square root mean? You're going to have an I. So this just pops out to become I. The square root of 36 is 6. But I don't want to write it like that. How do I want to write it? 6I. I want to write it as if it's a variable. Just making a little bit of sense. Teeny bit? Okay. Here's what I want you to try to do. These are problems like we were doing earlier today and yesterday. Try them on your own. You might get an I that pops up. That's okay. It's not the end of the world. Now you know what to do with the square root of a negative number. So try these on your own, and if you get an I, that's okay. Okay, I got to get this by itself. What do you want to do? Subtract 8. Now what? Divide 2, I get x plus 4 squared equals -25. Square root it. Okay, remember, you are not going to distribute. You're not going to distribute that. You're not going to do it. You are going to just take the square root. So it's x plus 4 equals plus or minus the square root of -25. Let's just deal with that now. What's the square root of -25? 5 what? 5I. So it's x plus 4 equals plus or minus 5I. What else do I need to do? I got to subtract 4. So is it plus minus 1I? No. I can't just take 4 away from 5I. They're not the same number. I can't just combine them. So how am I going to write it? Well, -4, right? -4 plus or minus 5I. And then we're done. Cool? Cool. Okay. We don't have that much more to talk about. We are mostly going to talk about how we do operations with imaginary numbers, so like adding them, subtracting them, multiplying them. This is up here to show you that this is how we write an imaginary number. You always have the imaginary part last, is pretty much the main thing here. So the I part is always written at the end, okay? And notice how it's BI, not IB, right? So treat it like a variable and put it at the end. So let me show you when this is going to come up. Let's say let's zoom in a little bit. So we're going to do operations with these things. That might look really strange. 5 plus 7i plus -2 plus 6i. Might look weird to you. There's a pretty easy rule that we need to follow that is going to make this hopefully feel a little bit more simple. Here's the rule. You are going to treat I like a variable. So pretend that I is the same thing as X. And then you just do everything the same way you would have normally done it. So at this point now, all we got to do is combine like terms. We're adding. So I do 5 plus -2, and that's 3. And then I do 7i plus 6i. I just pretend it's like a variable. So you're combining like terms. So it's 13i. And that's all it is. That's it. Treat it like a variable and combine like terms. That's all you got to do. Does this make sense? Let's do one where you subtract, because it gets a little bit different. Instead of adding, we're subtracting. So you got to pay attention to this. It's 8 minus 2. That's 6. It's 3i minus 4i. What's that? -1i, right? So it's just minus I. And that's all it is. Does this make a little bit of sense? All right, one more adding and subtracting, and then we'll talk about multiplying. This one's kind of goofy. I have 7 minus all this stuff. So I'm subtracting each of these pieces, and that's where it gets kind of goofy. I'm doing 7 minus 3. Well, that's 4. That's easy. But a lot of times students will have the tendency to just write plus 2i at the end of this. But that's not what we get, because we're subtracting 2i. So it's minus 2i at the end. You're subtracting both of these pieces. If you want to think about it like you're distributing the negative sign, you could think about that. So then it's 7 minus 3, and then it's minus 2i. But if you're subtracting an entire quantity, you're subtracting all of it, not just one piece of it, okay? So you got to be careful with that. Do we have questions on any of these ones? No? All right, then let's talk about multiplying, and then I'll be done talking to you. Multiplying, it's the same way. Just treat it like a variable. But there's one more thing I got to add in here. Remember, if I is the square root of -1, that means that I squared is just -1. So if you come up with an I squared, you need to turn that into a -1. And it'll change some things a little bit. So if I'm multiplying these, pretend like it's just like an X. It's just like a variable. So 5 times -4 is -20. I times I is I squared. Yeah, but I squared is -1. So that's -20 times -1, which is +20. Now the I goes away. So sometimes that happens. Does that make a little bit of sense? Yeah. It just changes the sign if you have an I squared. All right, let's do one that's a little bit different. Who learned FOIL? Do we know what that is? Some of us, foiling, first, outside, inside, last. We're going to talk about that more later. I have a hatred for FOIL. We'll talk about that later. For now, if you see one like this, if you were taught how to FOIL, you could FOIL it. It's okay. We're going to talk about it later. I prefer double distributing. It pretty much just means that you're going to distribute both of these things into this one at a time. So first, let's do 2. I got to do 2 times all this stuff. 2 times -3 is -6. 2 times 5, I just treat it like a variable. What is it? 10 what? 10i. All right, so I distributed the 2. Now I do it with 3i. Just multiply it into both those pieces. 3i times -3 is -9i. 3i times 5i is plus 15 what? I squared. Because I times, it's just like a variable. X times x is x squared. I times I is I squared. You get what I mean? You're just pretending like I is a variable and doing everything the exact same way you would. All right, so now we can combine some like terms here, right? I can combine these two things. I'm treating them just like variables. I have 10i minus 9i, that's 1i. So now I have negative 6 plus I plus 15i squared. But what is I squared? 1, negative 1. So that turns into 15 times negative 1, which just makes it negative. So it's negative 6 plus I minus 15. I can combine some like terms in the end here. Negative 6, negative 15, put those together. That's negative 21 plus I. And notice how I have I at the end. I is at the end. We always want to write it like that. It's just procedure. Does this make a little bit of sense? So big thing to remember on this, I squared turns into negative 1. Treat I like a variable, do everything else normally, okay? Do I have another one? No, I don't. Wow.